All right, so today we're going to do special cases of factoring. Now, the process of factoring does not change at all for the special cases. It's just the special cases actually are easier than what you've been doing. So, let's pedal on our special factoring. The reason we don't start with a special case is because it's almost too easy to start with, and it leads you down a path of wrong assumptions. So let's start with the first special case. X squared plus 10x plus 25. And you might say, well, why is that so special? In fact, you might have even had a case like this already. So let's give it a shot. Let's factor it. Go ahead, Ryan.
You gotta get rid of the like.
And there's nothing like.
What?
But what about the x?
This x squared doesn't have 5.
See, I know, but it was the x.
Nobody cares about that.
There's no 5.
Okay, anyways. Going on.
Okay.
So we're on this, but continue.
Me?
Yep.
X. What am I doing? Oh. 5 and 5.
Yep, 5 and 5. And notice that these are, and this is why it's a special case, these are the same. Okay? So we could leave it like that. That's not wrong. We could also write it like this. X plus 5 squared. Okay? So that's another way to write it. These mean the same thing. Which just brings me to a reminder. Tell me about this. If I have x minus 3 squared like that, is that x squared minus 9?
No.
No. What does this mean? It means x minus 3 times x minus 3. Let's multiply that out. What do we get?
X squared.
X squared, then negative 3x, and then negative 3x again, and then negative 9, into plus 9, plus 9.
And I get x squared minus 6x plus 9. Alright, so this first special case has a name. It's called a perfect square trinomial. And I don't really care whether you can name it or not, just sometimes this happens where you get the same thing. So I'm going to put up 2 more perfect square trinomials. And I want you to factor them.
I'll learn my multiplication tables.
Yay! I'm very proud of you.
Thanks.
I'll let me guess, you did all 3 of them.
Yes.
Okay. Trey's going to give us the first one.
I would give you x plus 6 in the same way.
Yep, they're both the same. And we could write that as x plus 6 squared. Okay, someone else. What do you get for the second one? How about Reagan?
X minus 8 and x minus 8.
Yep, which we can box that. I won't mark it wrong if you leave it like that. Well, we could write it like this with a little square. And someone else. Perhaps Alexis, the last one.
X minus 10. X minus 10.
You see what I mean? These would be almost too easy to start the chapter with. Because the ones that you've been doing don't end up like that at all.
This is too easy.
Okay, so that's the perfect square trinomial. Let's get the next one. Oh, welcome to geometry class.
Yeah.
Let's get rid of that. We don't need that.
Something that I could have done.
Okay, so the next is the difference of perfect squares. Now there is a tricky thing about the difference of perfect squares. But let's just try one before we get into the thing. So let's say I have x squared minus 64. And notice here, it's not a trinomial, it's a binomial. And notice, normally I have like an x squared plus a bx plus a c. Normally this is what I have. What's my middle term?
1.
Well, let's see what happens. What if I did, now with the ones that we just did, we had something like this, right?
0.
And then let's multiply that out. Get x squared plus 8x plus 8x plus 64. And then when we get the middle, right, get 16, focus on your own desk. Sir. Thank you. Okay. For the difference of perfect squares, let's do the same thing, but maybe instead of them being identical, they have one little difference. Let's see what happens. X times x gives me,
X squared.
and the next one,
Minus 8x
and the next one,
plus 8x
and the next one.
minus 64.
Get x squared minus 64. Do you see what happened to the middle term? What's negative 8 plus 8?
0.
0. So what is the middle? 0. It's 0. So when I factored these, I need factors that give me a 0. So what if I had x squared minus 100? What goes in front?
X's.
And then factors of 10 that when I combine them give me, or 100 that I combine and get a...
I'd say 10 and 10.
Yeah, 10 and 10 because Mr. Kane just said it.
Oh.
And also, you know, all right. But one's minus and one's plus. Let's do one more together. I know one that'll get you.
Oh. Are you sure about that? Cool.
Oh no, there's two variables. Freak out. Get your undies in a bunch.
I'd say 2x.
We would start with the factors of 4 that are closest together, which is 2x.
Then plus minus. And I'd say 5y.
Yes. Now, how does he get that? 5 times 5 gives me my 25, and y times y gives me my y squared. And let's see what happens when I multiply that out, just to check. So 2 times both of those, I get 4x squared minus 10xy. And then when I do the 5, plus, now it would be yx, but I'll write it in the correct order. And then minus 25y squared. And notice what happens to the middle. Cancels. And that gives me that. Okay? So the difference of perfect squares and perfect square trinomials are the easiest to factor, but there is one little trick. What about this one? Now, you might think that this is what almost every student in the world does, and they get it wrong. You ready? They do it like they did this one. What did we get for that one?
X plus minus x and x in there.
Okay? That's correct. And notice why it works, because I have this plus 10 and minus 10, which gives me negative 100. And then here's what almost every student in the world does. They write the same answer. But these are completely different, because this is a plus. And notice, what's 10 times negative 10? Negative 100, but I have... So then some students, recognizing that problem, are like, oh, I'll just put a plus here.
It's either plus or negative.
Now, let's multiply that out. What do we get? X squared plus 10x plus 10x plus 100. Does my middle term cancel?
No, because you had negative.
So we get this circular reasoning thing, and we actually need to arrive at this conclusion. Not factorable.
Ooh.
Not factorable. At least not for an Algebra 1 student. An Algebra 2 student would be able to do this.
How?
Magic.
Yeah, that's some really good magic.
I want to say you should teach us right
The
now.
magic will be on the honors test. Okay, anyways. So, what is the key here? You cannot factor the sum of perfect squares. I want you to try the board that I put up.
Ian, how do you expect them to do it in honor test if you haven't taught them how to do it?
Then we'll find out.
Just them?
Yes. Actually, let's do. Okay, we'll do 4. Factor those.
What? X times X equals 81. What difference?
Up to 81.
29.
Okay.
I thought you did your multiplication tables.
I learned the simple multiplication tables.
You haven't gotten up to
1
that yet.
times 1, 1 times 2.
All right, first
I don't
one.
know 19, you know how you got that.
Taylor, what'd you get for the first one?
K plus 5. K minus 5.
Good. Second one, what'd you get, Reagan?
X plus 9. Y minus
And the third one, the Barbarian.
X. 8. No, my bad. 4
There you go.
minus X plus 4.
And the last one,
Not factorable.
not factorable.
Unless you're in algebra 2 or in honor, because they're going to get screwed up.
Okay, not factorable. You cannot factor the sum of perfect squares. All right, that brings us to the final big kahuna of the big kahunas of today, which actually are pretty easy. We'll just do 2 of them. Nah, 3. Why not 3? Why not? The first step of all factoring is always take out the common thing.
So that would be a 3 in here.
Yes. So we'll take out a 3. 3. What does that leave on the inside, Sarah?
5.
Continue. Minus Meredith.
Minus 4.
Minus 4. Okay. So now we have m squared minus 4. We're going to separate this into 2 pieces. So we're looking only at this. Continue, Taylor.
M minus. Wait a second. Is this where you're doing the thing when you do the 4? What is
Sure. What are the factors for 4?
it? 1 and 4 or 2 and 2. So 2 and
2.
2. M plus 2.
Yeah. Good. We know it's not going to be 1 and 4 because what's my middle term?
A negative.
No, the middle term is
oh.
actually 0 because it's not there, which means I need the factors that are the same. All right, what's common in the second one? Austin.
I don't 150.
Well, I can't factor out a 1/5.
No, Jesus, what's that?
Who knows? What can I factor out of all of these?
6.
6 and
R.
R, which
Yeah,
leaves
R2.
what?
It'll leave R2, no, negative 25.
Okay, someone finished the factoring. How about Meredith?
R.
So do you see how I put that right away? Okay, so now I need, what's my middle term, class?
0.
0. So factors of 25, that would combine to a 0.
Plus 5 and then
Plus 5 minus 5. Now what's common in the last one?
3.
Okay. What's 192 divided by 3?
64.
Okay. So this is a perfect square trinomial. So what goes in the front of both of these?
X plus, yeah, plus pluses. It'd be A though. So I do my multiplication.
Got to your 8's, huh?
Yeah.
All right. Any questions on today?
Isn't it the only that I can do my 9s like moving the finger rule?
Going once. Going twice.
So.
Draw this one. This is a what shape?
That's a rectangle.
Supposedly. It is supposedly a square. And let's say the area of this square, let's say the area of that square is x squared plus 12x plus 36. Now since it's a square, what do I know about all the sides?
They're all the same.
They're all the same. So I'm going to ask, what are the sides? Now we're not going to get a number, okay, but we're going to get a quantity. Now the area of any square or any box is base times height. And in this case, both the base and height would be the same. They're the same thing. So what could I factor that into such that these two lengths are the same?
X, X plus.
And I heard this. If I multiply those two, do I get x squared plus 12x plus 36?
Yeah.
Yeah. Okay, give me a moment to copy that down. Any questions on how we got that? We'll do another challenging one here in a moment. And here we go. Just so that we can say we're done. Now this is not a square.
It's a rectangle.
Yeah. And I'm going to give you the area of this rectangle is 25x squared minus 121y squared. And I'll say this side right here is 5x minus 11y. And I'll ask, well, what's the other side? So remember that area of any rectangle or parallelogram is base times height. And this time I gave you the base is 5x minus 11y. I'm asking, well, what possibly could be that other thing that when I multiply them, I get this? And we would say,
No. 5x.
minus 11y.
not minus
Plus,
11y,
plus.
plus 11y. Because my middle term is 0. So that would be my answer right there. All right, we are done.